episode 4. And today we are looking at fundamental and derived quantity. Now, please, if you are watching this video, please help me to subscribe to this channel, JAMB Solution, and make sure you purchase your heart. You can see it in the comment below and the link. Now, today we are looking at what? Fundamental and derived units. Fundamental and derived units. What do you mean by fundamental? Now, in fundamental, when we talk about fundamental are what? Are known as what? Universal measurement. The generally accepted fundamental. When we talk about derived, we use this one to give out this one. I mean that we use this one to what? They combine this one together to form derived quantity. Do you understand? Derived unit. Now, what do we mean by this? The fundamental, we can use the word to understand the fundamental. In physics, remember, I said that physics is studying about what? Can you tell me? It's studying about the effect of matter. If you want to study effect of matter, there are some instruments that you can use to do that, yes or no? And all these instruments, they have their units. The length have their units. The mass have their units. The time have their units. And other substance like that. Like this one, mass, they have their units. I've told us instrument they can use to measure mass. Now, the instrument you can use to measure electric current. And what you're supposed to know that when they put what? This one, A is ammeter. Now, all these instruments, this one is for measuring instruments. Now, mass is for, the unit of mass is kg. The unit of electric current is ammeter. The unit of length is meter. The unit of temperature is Kelvin or degrees Celsius. Now, degrees Celsius means like this or like this. Now, time is seconds. Amount of substance is mole. And medium intensity is candela. They call it candela. Now, that's CD. Now, why are we doing this in physics? Well, anytime you are measuring, it must have something at the back. Example, if I write 3, 3, 3, 3, 3, 3. The 3 I write, if I begin to put something on it like this, put something on it like this, put something on it like this, put on something on it like this. Now, it has changed. Because this one is talking about mass, this one is talking about length, this one is talking about temperature, this one is talking about what? This one is talking about temperature, and this one is talking about what? Time. This one is talking about what? Mole. This one is talking about candela. Do you see? All this one, when you are measured, you must know that it will have unit. And the unit, they have its own specific thing that they are using to do it, one after the other. Do you really understand? Thank you. Now, you must understand in general, you must understand this unit. This unit, you must keep it in your mind. The mass is what this, the electric current is this, and this one is what? Fundamental unit. And we use, if you want to understand it very well, just use this acronym. META. M represents mass, E represents electric current, N represents length, T represents temperature, T represents time, A represents amount of substance, and L represents what? Luminous intensity. You can use this acronym to what? To get what this one means. The derive what? The fundamental quantity. Let us drive it to what? Derived quantity. We use this one to form derived quantity. What do I call it? We use fundamental to form what? Derived quantity. One after the other. Now, how can we do that? Now, in derived quantity, there is something that you need to know in derived quantity. Anytime they give us length, in what? Length represents height. It represents height. It represents breadth. It represents The unit of length is what? Meter. The unit of height is what? Meter. The unit of breadth is what? Meter. And the unit of length is that. All of them are what? Are length. Now, we use this one, combine this one together to form what? To form derived quantity. What are the derived quantity? Number one, we have volume. Volume. Now, what is volume? Volume is length times breadth times height. Now, this volume, combine it together. I told us that the length is the same thing as what? Meter. Times the breadth is the same thing as what? I'm talking about the unit of length, the unit of breadth, and the unit of height. The unit of length is what? Is meter. The unit of height is what? The same thing is what? Meter. Meter. When you combine all of them together, it becomes what? Meter what? Meter what? Meter what? Cube. Do you understand? This meter cube, look at it. We combine this. Three of them, combine it together to form what? Derived quantity. You see now, we use this one to form derived quantity. Another one, area. Area length times what? Breadth. This one represents meter. This one, another one, the meter. Combine the meter together, it becomes 3. Become what? 2. You see now, meter square. Now, another one, density or density. Density. What is density? Density is what? Mass all over what? Volume. What is the unit of mass? The unit of mass is what? kg. All over what? The volume is what? Remember, we have got the volume because the unit of volume is what? Meter square. Meter cube. We can now write this what? Kg per meter what? Cube. Do you see now? How many things they combine together? They combine about like 4 what? 4 fundamental quantity to get what? Density. We use this one to form this. That's why this one is acceptable. But the right quantity does not acceptable. Do you get it? Let us move to another one. Another example is what? Velocity. Velocity. What do you mean of velocity? Velocity is what? Distance all over what? Time. Or displacement. Displacement all over what? Time. Displacement all over time. The unit of displacement is the same thing as what? Distance. And what is distance is the same thing as meter. We use distance, displacement as what? Meter. And we use the height, breadth, length, and the same thing with what? The same thing with what? This displacement. Displacement is still the same thing with what? Displacement. It's still the same thing. Or distance. All of them they are still in what? All of them they are using what? Meter. Notice that. They are using what? Meter. Now, displacement is meter and time. You use what? Seconds. Look at it here. What? Time is what? Seconds. That's why we said meter per seconds. Meter per seconds. Now, let us go to speed. Speed equal to what? Distance all over time. Now, the distance is still the same thing as meter. And what? All over time. All over what? Seconds. And meter per second. Do you see now? All this one, they are your unit. This is the unit of speed. This is the unit of velocity. This is the unit of what? Density. This is the unit of area. This is the unit of what? Of volume. All of them have their own unit. And they use this one to form what? This. Another one is acceleration. Acceleration, we use A for acceleration. Acceleration equal to what? Now, I want to explain the difference between what? The speed and what? Velocity. This difference between speed and velocity, let us assume we have like this. A man walked from A to what? To B. Look at it. He moved from A, go like this, go like this. Now, this one. Now, when somebody move from A, go to what? To B. We call this one, and assuming if we want to work it perfectly, we straight to B without giving any. Now, what they call this one? This one that move from here, here. Now, this is normal. Now, I just want to use normal to draw the what? The line. That it will form an angle. Go the direction of this. Now, when you are moving. Now, this one does not have specific direction. Look at which one that does not have specific. We cannot tell that this is where we are going. And you go again, and go by like this. It doesn't have specific word direction. We cannot say that it's going to direction 50 degrees. We cannot say because when it reach this place, another direction. When it reach this place, another direction. When it now come to this another direction, it just going. It doesn't have word. This line does not have any specific word direction. What they call it? They call this one what? They call this one distance. Now, distance does not have specific word direction. But look at this one. Just this one goes straight. We can call this one like 60 degrees. That you are moving in what? If I'm going like this, I know that I'm walking in what? 50 degrees. Or if somebody says, go straight to 90 degrees, you know that you are walking straight to what? To 90 degrees. This one has its own, number one, it has distance. You know this one go like this, but it doesn't have specific word direction. But it has distance, moving, distance. But look at this one now. This one is, now distance, we can call this one magnitude. What I call it? Another name for distance is what? Magnitude. Notice that. The another name for what? Distance is magnitude. Now, this one, it has what? Direction. It has what? Direction. What is the direction of this one? Is what? 60 degrees. The direction of this one to the A is 60 degrees. And it doesn't pass any corner. It goes straight. And we can take this one as distance from here to here. Are you hearing me now? This one has what? Number one, distance. Distance. Now, you have distance and what? They call the distance magnitude. And what? You have distance and what? You have what? The magnitude and what? Direction. Remember now, this one has magnitude and direction. And we call this one what? We call this one displacement. What is displacement now? Displacement is the one that have the what? Both what? Magnitude and what? And direction. Now, distance is the one that have only magnitude. What's the meaning of magnitude? Distance. Just only the distance, but there is no direction. But the what? The displacement is the one that have the both magnitude and direction. I'm giving you the meaning of what magnitude. Magnitude means what? Distance. And direction means the degree of that where that thing is what going, whether it's 90 degree or what? Or another what? Degree. Now, do you understand now? Thank you very much. If you understand, comment. Now, let's move to the next one. I'm giving you the word, the meaning of what? Displacement and what? And what? Distance. Notice that. Now, what do we mean by, we have talked about the word, the speed. The speed by itself, the speed. Now, let's move to the acceleration. Acceleration. We use A for acceleration. Acceleration is what? Velocity all over what? Time. Remember, I mentioned velocity here. V, we use V for velocity. Now, velocity, what is the unit of velocity? The unit of velocity is meter all over seconds. And this one half seconds again, all over seconds again. If you are working with this, this one will now be what? Meter per, this one without each other will now be L squared. If I have something like this, 3, like if I have, even, look at it, this one is what? Fraction, because this one is fraction. Turn this one to fraction, the same thing, all over 1. It becomes what? M all over S. The fraction of this times, because there is a division between this and this, it will now be what? This one will turn upside down, it become 1 all over S. This one will turn, it become M all over this one S. You can now write it as what? Meter per second squared. Now, the unit of acceleration is what? Meter per second what? Squared. Notice that. Now, let's move to the now. Another one, force. What do I call it? Force. What is force? Force is mass times what? Acceleration. Say it again. Force is mass times what? Acceleration. Remember, what is the unit of mass? What is the unit of what? What meter per second what? Square. It will be what? Meter all over S square. Now, this one to fraction all over 1. This up will times up, down will times up. It become what? Kg meter all over what? S square. Now, this is the normal unit. Because they use this one to form what? To form derived. They use what? Fundamental to form derived unit. Remember, that's what we are talking about. Now, in this, now, do you see that he has many units? That's why we don't use this one. We now call all this one the same thing as what? Newton. What do I call it? Newton. Notice that we call it what? Newton. Now we call this one Newton. If you have anything you can offer or marker, and you see my phone number, just send, and that's to make other people enjoy more. Now that's Newton. We call this one Newton. Remember, I told us that the physics is study about the what? Effect of matter. All those measurements, the instrument you can use to measure, they have their own unit. Now we are talking about the unit now. We have those units, we have derived units that we will be putting at the back, and we have what? Fundamental unit. Now to understand the fundamental unit, that's why we have this one is fundamental and this one derived. You see, I'm deriving it using the what? The fundamental to get the answer. Now move to the next one. We are moving to the next one, which is what? Momentum. Momentum is what? Is now the momentum we have. Let us look at energy. Before that, energy. What is energy? Energy is force times what? Distance. Energy and work, they are the same thing. Work. Energy and work, they are what? They are the same thing. What is this? Energy and work, the formula and work are the same thing. What is the unit of force? The unit of force is what? Newton, which we have given in us here. And what is the distance? Remember, distance they normally use what? M. They use M. It will not be what? M. If you want to find the what? We use M and what? M. Remember that the M is to have many what? Many units combined together to give us this. That's why we cannot accept this one. Now that's why we call what? The energy or work the same thing as what? Joule. What do I call it? The unit of what? Of work is what? Joule. Remember, it's still the same thing. This is still the same thing with this. Are you getting me now? Now I need to clean it up and go further that we can get. What about work? Work. Now work. Let's not look at what? Work. What is work? Work is energy. Energy all over what? Time. Now, what is the unit of energy? Is what? What is the unit of energy? Is what? Joule. Now, it will now be what? What is the answer now? It will now be Joule. Joule all over. Time is what? S. It will now be Joule per second. That's how the way it is work. Now, you can see it by yourself how everything works. That's why I challenge you to go and look for the right quantity and what? Work all of them out. That's another thing. Now, you can see that we use what? The fundamental to what? To bring out what the right unit, to give us what the right unit. We have a lot. You can work it more by one. Momentum is there. Even some of the, you can go further. You have no it. My own is to guide you that you can walk further. Now, I know you will defeat this jam this year. Thank you. And we are going to next one, which is episode 5. And we are looking at what? Dimension. What I call it? Dimension. See you. Make sure you subscribe. Tell your friend, tell your neighbor that there is something going on in the world jam solution. Thank you so much.